Hello, everyone. Welcome to another episode of the Code and Coffee Show. It's the show in which we talk about two most important things in the life of every developer. So, about code, because we spend most of our time coding, and about coffee, because it runs in our veins and yeah, it helps us create all the different stuff. And today we will talk about how to secure a Git repository because this is sometimes a bit of a overlooked vector of attack that we miss and some people can get use of it. With me, I have Dwayne McDaniel. Dwayne has been working as a developer relations professional since 2015, and he has been involved in tech communities since 2005. He loves sharing his knowledge, and that's why he's here. He has done it by giving talks at over 100 events worldwide, and he lives in Chicago. And outside of tech, he loves karaoke, music, and performing improv. So we can see that Dwayne is really a person of so many talents at once. I mean, really, improv is not a typical hobby.
I think it should be a more common hobby, really. I know that's not what we're here to talk about, but if I'd encourage anybody out there to find a local improv class, an improv team that offers workshops. It really helped me with my public speaking, being able to think on my feet, and really, it's just a lot of fun. So that's just a generic plug. Go out and find an improv class, and you'll probably enjoy it.
Interesting. Who knows? Maybe I will give it a try because why not? So before we will start talking about the Git security part, tell me, are you a coffee drinker?
I am. I drink coffee every single day I'm awake.
Which type is your favorite? Do you have any favorite brand or type or?
There's a local coffee shop here in Chicago. I shouldn't say coffee shop. They're a coffee roastery and distributor. The coffee tree, the coffee bean and tea tree is what they're called. And they are locally owned. It's really one guy, and he gets coffee from all over the world. And through working with him over the last couple of years, I've really honed in that it's specifically there's a Tanzanian peaberry that he does a light
Mhm.
roast of, and that is my standard. It's what I hold all of their coffee up to. After that, I like Rwandan and Egyptian beans, but give me a light roast over a dark roast. But if I'm on the road, I'll drink anything, and I'll even drink conference coffee. And as you know well, Majik, that's the worst coffee
Yeah,
on the world.
that's the worst coffee ever. I mean, they differ. They differ because I remember that at some conference it was much worse than on the other.
Mhm.
But when I was organizing one, I was kind of crying because I knew how much we paid for it and how awful it was. So it
It's
was the
always
horror.
really it's always a
Yeah.
really bad sign when you see any kind of flame underneath the coffee pot. All
Yeah.
you're doing is burning the coffee at that point. I get the intent is to keep it warm, but I'll take room temperature coffee that was brewed correctly over burned coffee any day of the week. That's part of the reason I don't like Starbucks is their typical roast is a little too burned for me.
I wanted to say that I totally agree with you. The first time, because especially in my city, we had Starbucks quite late. It was, I don't know, 5, 6 years ago. And I remember that I decided, yeah, I will go and give it a try to see the most famous Starbucks, right? And my first impression was, yeah, it's kind of overburned. So, no,
Yeah.
thank you. I mean, and Starbucks never became my favorite brand. So,
So if I walk into a conference, my favorite type of coffee at a conference is if I go in and it's in the big cardboard boxes with the bag inside.
Mhm.
Generally, that's the best way to get coffee. It actually keeps it a good temperature for hours, and there's no additional heat that keeps it burning. So however it left the brew, that's how it's going to taste for the rest of the day. Uh, if I need to warm it up, there's probably going to be a microwave somewhere I could use, but yeah.
I will be honest. I never thought about microwaving coffee. I don't know why. I prefer to go with a bit more colder and give it a try because it also changes taste, especially those light roasted coffee. So sometimes they have a totally different taste when they are warm and when they are colder. And very often the cold one is a bit better because
Mhm.
some tastes just start taking over. So yeah, really great to hear that I also have a light roast fan with me because I'm also, and I can even tell you that I have a Rwanda with me. So
Nice.
it's I just done it in my Hario V60. So
Mhm.
um
Well, speaking of
yes. Mhm.
cups as
Oh, I see
well,
that.
um,
I see.
this is my daily driver for my coffee cups. This is an insulated Yeti coffee cup, but I got it from WordCamp Boston. I believe 2019. It was the year, but it was their 10th anniversary year, and this was the speaker gift. So I gave a talk there, and this is what they gave me. And I've gotten a number of speaker gifts over the years, but this is the one I use day in, day out. It keeps my coffee the exact temperature I want it as I'm drinking it. No fancy equipment needed. It's one cup.
True, true. Yeah, so before we will jump into securing Git, yeah,
Sure.
having a show like this requires some money. But thanks to Kinsta, they are covering most of it. So the next 20 seconds are done.
Kinsta's application hosting simplifies the work of modern web developers. With just a few steps to get your app up and running with performance backed by the fastest Google C2 machines, Kinsta has built a development platform designed to get your applications in front of users as quick as possible. Test Kinsta's application hosting for yourself at kinsta.com. The first $20 are on us.
Okay, so we are back. So yeah, we are going to talk about securing Git. Um, so let's start from the top. What is the most common breach that can happen by storing our files in a Git repository?
That is a very broad question. So to preface this, currently I'm working in a company called Get Guardian. So I have a very specific worldview of how breaches occur and how to think about security. And it all really starts with what you're storing in that repository. The number one way a breach gets worse, maybe not initially happens, but a lot of times it happens that way, is that a plain text credential is left somewhere in the code. Even if it's a private repository or in a private lockdown environment like Circle CI, uh, not to pick on them, but there was a recent breach that they announced earlier in January.
I think
Um,
breaches. I think
yeah, multiple breaches.
it was a series of it.
But that's the common among all of it is that once an attacker gained access, the very first thing they did was look through the code and found, hey, we have more keys to try. Let's go try them. And
Mhm.
unfortunately, that is typical in almost every attack we have seen over the last several years. So that's the biggest threat of source control is storing hard-coded credentials, what we think of as secrets here at Git Guardian, in your code base that you're storing in Git. Um, there's a lot of potential danger. One, someone can breach in and leak your code. We saw that happen to Samsung last year. Uber had a lot of credentials hard coded into PowerShell scripts inside their private environments. But we also know that private code doesn't always stay private. So the nature of Git is you have the entire history, every single version of every file, which is awesome, but it's also very dangerous that way. That that's what we saw happen at Toyota last year. Was part
Mhm.
of their T Connect repo got pushed publicly somewhere where they weren't expecting and somewhere where they weren't looking. It contained a single data key to a server. That data server contained like 297,000 customers' data, and it took them
Ooh.
5 years to figure that out. Is that Git's fault? I don't really think so. I think Git is a tool like anything else. It doesn't make your code any more or less secure in and of itself, but it's also one of the trickiest to master technologies on the planet. And uh, I think there's a lot of reasons for that we can get into. But as a result, people can do some dumb things with it, not thinking of the long-term ramifications. One of the other big issues we see is forgetting that that entire history is there all the time. So if someone does hard code credentials and then thinks later, like, hey, that's a bad idea, we should fix that, and just simply takes the credentials out,
It's
that
still
doesn't solve the
there.
problem. Those last commits are still in there. They're still compressed. Anybody that gets their hand on the repo, even if it's an old commit, I mean, it's still in there. You can unpack pack files all day and get at every single object that was compressed at any point you want to. So thinking, hey, I've taken the secret out of what's going to production, that I've taken it out of head. That's great, but attackers know how Git works very well, and they have bots that automatically start scanning through the entire history to see, well, what's in here? What can we exploit?
So, what would be the simplest way to make sure that our code is secure?
I'm going to say, just because I work for one of these kind of companies, use scanning tools to
Mhm.
automatically detect hard-coded secrets and for misconfigurations. If you look at the OWASP top 10, I don't know if your
Mhm.
audience is familiar with OWASP, the open source web application security project. Uh, awesome open source, OWASP.org. But they put out a report every year of the top 10 vulnerabilities they see happening out in the world. Unfortunately, misconfiguration and encryption failure, including, we've published secrets in hard code, or in plain text in our hard code. Uh, we've hard coded plain text secrets throughout our code base, is a growing problem. Those are
Mhm.
only climbing up the list. I'm actually very curious to see the report this year, see where they actually pop out from last year's data. But I don't think they're going to go down in the stat. There was like number 2 and number 3. Um, so using static analysis tools that can look for um, any kind of secret will help you prevent it. But ultimately, don't hard code your secrets. If everyone just did that one simple thing, then the world would be a lot safer. And the natural follow-up question is like, well, how do you do that? You have to hard code sometimes. Um, actually, you don't. It's very easy to think like, hey, I need to hard code this. Actually ran into this earlier this week with a Django project where someone really was adamantly believed they needed to hard code a secret. And I'm like, well, no, you can use an environment variable locally because you're just spinning this up locally as a test. And then once you put it onto GitHub, like I pointed in the documentation, like this is how you embed secrets in GitHub and then programmatically call them. Like it's pretty straightforward to do.
Mhm.
But the problem is it's an extra step. And just learning the technology, now you have an entire other layer of technology. And you'll see a lot of blog posts out there, a lot of experts say, just use HashiCorp Vault. But that is a giant, really heavy hammer, which is awesome. It is the gold standard of how to manage secrets programmatically, but it is also kind of complex to learn. It's kind of
Mhm.
overkill in a lot of people's opinion when they're working with like small personal projects. The problem though is, well, one of the problems is that if you get in the habit of, well, I'm just going to hard code this just temporarily, just for local setup, you'll forget you did that. Like you're working with multiple files across a lot of environments. It's pretty easy to forget that you hard coded something once just for convenience sake and you meant to take it back out. Uh, we put out a report every year called the State of Secret Sprawl.
Mhm.
And I know we're talking about Git, not Secret Sprawl, but that's where we're finding these things is in Git repos. And from the looks of it, from our analysis, we don't think most of it's malicious. We think the vast majority, over 80%, closer to 90%, according to last year's report, looks like it was left in there by accident or was put in there temporarily and probably should have been swapped out. So it's not people maliciously, hey, I'm going to publish everything in Git and hope that people attack me. It's, I got a job to do and I just got to get this thing working. I got to make sure the API endpoint works and I'll set up the Vault later. And then Vault never happens.
I mean, we have this saying in Poland about those temporary solutions that, for most occasions, are left for years and they are the most stable ones. So this is something like this with hard coding. It happens very often, and also if we look at many solutions, for example, let's look at the most popular CMS out there. I mean WordPress.
Mhm.
It default method of storing all the database credentials is hard coding a WP config file, not through .env or something like this. It's by hard coding, and if we start hard coding, it's very easy not it, to forget just ruling it out by using, for example, gitignore, which is one of the methods. Yeah, and about this, gitignore. This is, I think, one of the most basic, but one of the most useful tools that will help us in preventing of
Oh,
uh, of. Mhm.
absolutely. So while Git doesn't make your code any less or more secure, they have provided a pretty clear, straightforward path to ignoring things and not including them in your source code. And that's the .gitignore file. For those of you who don't know or haven't used it, it's a simple file you can create .gitignore. It doesn't exist by default in a new repo. It probably should, honestly, and just be
Yeah,
blank.
I
But
really, or even with a small comment, remember.
mhm. I mean, if we still have rev parse and the example git hooks, we should definitely be including a blank or an example .gitignore at this point. We should write gitster and get that in the next PR. But gitignore is a file that anything you list in it will be ignored. You can list specific individual files or entire types of files or entire directories. So if you are working locally and you have a test environment that are a bunch of tests that you built that you don't want to share, you just built them locally for testing reasons, you can ignore that entire test file. And when you push, it won't push those things. What's become very common is to use a .env file to store your credentials and then programmatically call them from the operating system to go look in that file and pull over that line. So that's very common, especially like Python. You'll see like import OS and then call from the OS, like where that file is and the line from that file you want. You do that differently through different tools. Hash Court Vaults, again, has its own methodology that you'll see out there. But you brought up WordPress and hosting. Again, this is one of those things. If you're just spinning up locally in your local environment, there's really no danger for, hey, I got WordPress working on my flywheel or whatever Doxel or whatever tool you're using, your Docker containers. The problem is that you push that and you're exposing credentials, but it also gets you in the mindset of, oh, this is the right way to do it. So when I go to hosts this somewhere like Kinsta or Pantheon or where have you, you think, well, I need to hard code this in. Fortunately, hosts, for the most part, have put a halt to that and said, no, you're going to use our secret credentials. And I know Kinsta is one of the leads in that, where you go through and it's like you just plug in the environment variables, you hide those environment variables within the system, and then they're just programmatically called. So if you're using like AWS and you're just doing this completely on your own, you would use AWS Key Vault to go in and do the same thing. There are a lot of advantages to doing it that way because, one, you can have all of your secrets in one place. So your developers and your security team can all agree, like, here are the secrets. There's no secret ones that we're sneaking into code for a system that security doesn't know about. No, they're all listed here. So when they do an audit, it's very easy to say, like, all right, they're all right here. Also makes rotation really simple. That's something doesn't get talked about a lot, but it's a really, really good idea to rotate your secrets often. If you can get by without ever using secrets, like using third-party certificate authorities or like an IAM, using short-term access tokens that get automatically created and rotated, you should be doing that. But if you do need a long-term credential, you should be rotating those regularly. And having them in one place, you can audit them occasionally to say, hey, this is the same as it was last time. We need to rotate this now. So a lot of advantages to doing it that way. But anyway, that's the I kind of feel like we've strayed far from Git at this point and really talked about best practices of setting up WordPress.
Yeah, but still, it's all kind of connected because we are all using the same tag. I mean, Git, and the practices are kind of universal because it won't matter what we use. I don't know, Python, PHP, Node. Always the ways to either make the mistake to breach the code, so hard coding it doesn't matter in which language we'll hard code it, versus the way how to secure it. For example, let's start with this gitignore file. But in general, you mentioned the key vaults. Could you say a bit more and how to start with it, how it works, and because this is because right now I think that the .env file became one of the most popular method of storing everything, which, as we know, is something opposite of secure because it's just plain text. So the vaults.
Let's start with env files, as it was a good idea at the time, but as the world has evolved, it's become less and less a good idea. And there's two main reasons why. One, as we moved more and more to cloud environments, throwing a .env file in a cloud environment, you might as well just be publishing it out to the world. Just assume that cloud environments are going to be at some point exposed somehow, some way. So using just an env file, that's one of the first things people are going to look for. Two, if Git repos, and this is something I was going to talk about later, but this is a good point to interject it. If you're only ever pushing Git repos around using Git to Git hosts, then yes, env files will stay out of your repo and it won't be a big deal because gitignore will simply ignore them. However, there was a report last year. It was I'm looking up the number. It was almost 2 million. I don't have the exact number in front of me, but it's almost 2 million Git repos were found in places other than Git hosting. And a lot of those had some kind of secret or env file or some kind of thing that they shouldn't have pushed included, because gitignore doesn't work if you just copy paste a folder. If you throw an entire Git folder into S3 buckets, that's not Git hosting, that's folder hosting, and everything in that folder is coming across. So those are the two biggest pitfalls I have seen recently about env files. There's also someone breaches your machine. Now they have access to that as well. But anyway, key vaults. Every cloud provider has some sort of service, and they all allow for third-party integration with the tool of your choice. I'm going to mention HashiCorp Key Vault more than I probably should, but again, it is kind of the standard out there. In your code, you will put it inside of a centralized management vault. Then, however that system, however that platform directs you to, you'll simply call it from that central storage at runtime. So instead of embedding Django key equals like the 50-letter key that be auto-generated, it would be the environment variable for that system. I don't want to like call any specific one out, but not save confusion. But like it would just be that little snippet of like, all right, that's going to get called. If an intruder gets their hand on your source code, but they don't have access to that vault, good luck. They're never going to figure that out. They know you use Django, But now they're starting from square one of like, now I have to guess a 50 character string if I'm going to try to attack that particular vector. And we're not even going to start with that. But like I mentioned it earlier, it gives you the one place to audit what secrets are available, and gives the security team insight into what tools are even being used.
And on the other hand, doesn't having a centralized vault also kind of a dangerous approach, because then you have one vault in which you have everything. Isn't this? I mean, I know that HashiCorp is a very serious company, so they are thinking about this vault very seriously. But I can imagine that there are more companies that are doing this, and
it's one of the things about just generally how they work is they're not storing your plain text credentials in a vault. I mean, you're entering them plain text, absolutely, but they're being encrypted in place and unencrypted through key management. So you're providing an encryption key at some point to authenticate, or I'm sorry, you're providing authentication at some point throughout the system to say, yes, this user is absolutely authorized to access this service, which will then bring in this key. It's done through certificates or through short-term tokens or long-lived tokens, depending on the system and your particular setup. But that is what unencrypts the data and allows it to be used programmatically. So even if someone does like, hey, I've downloaded your HashiCorp Vault database, good luck. It's just a bunch of binary. It's nothing human readable. It's something that you would need a pretty complex key to unlock in and of itself, which is normally not ever stored in plain text or shown. This is the advantage of using IAM, identity and access management, is you're connecting up users to roles, and those roles grant permissions to say, all right, you can access these particular systems. So it handles all that encryption and all of those handshakes on your behalf. And I say IAM, most people I automatically identify IAM with AWS because they called their service IAM, but it's just the general notion of how, of who can access what on a system. That's all IAM is just a general concept. Of course, AWS called theirs IAM. Google's is called IAM as well. I forget what Azure calls theirs off the top of my head, but all cloud providers have some way to manage this. If you dig through the docs, you will find some way to talk about environment variables and securing those environment variables in their vaults.
I understand, yeah. And because you mentioned earlier on that that this way of getting all the leaked passwords is, let's say, getting more and more popular. Why do you think it's happening like this? Is it because I don't know, Git itself is getting more popular? Because I also think that might be one of the reasons.
Git is getting more popular in the same way that living indoors is getting more popular. There are simply more people to do it. GitHub has gained, I want to say, close to 90 million users in the last 3 years alone. It's ridiculous how many people use just GitHub. Therefore, they use Git. I mean, GitHub is just online hosting with a bunch of services around it. So the number of Git users is only going up. As new users come online, as I mentioned earlier, Git's a weird thing in the computer science space because almost everyone that uses it is self-taught. They pick up just the pieces they need just to figure out how to do their job. No one starts with a very high level of like, all right, I'm going to learn Git and I'm going to go through a security module for that to figure out all the best practices for that. It's like, no, there's a sign someone pasted on the wall that literally says git commit, git push, exit building in case of fire. It's that old XKCD comic. It's like, no one knows how it works. Just run these 6 commands. And if you need anything else, call this guy. If he doesn't know, just blow up the repo and start over. That's how people think about this mystic art of Git. So anyway, back to your point. I think we're seeing so that really does lead to a world where people that it's not the people that have been using Git for years making these same mistakes over and over. They're learning, they're adopting Vault, they're adopting env files locally, they're learning their lessons and maturing. But every single year so many new people come into the ecosystem and are learning from scratch. They're hopefully watching the right videos and reading the right things, but at the end of the day, they're just trying to get their Django project up. They're just trying to get their WordPress site hosted somewhere. It's that giant learning wall they have to, as they're learning, they hit this wall of like, all right, now I need version control, and they'll get through wherever they can in it. Not like we got to go all the way to the top and learn everything there is to learn, and then we're masters of it. So that's why I think we're seeing just the increase year over year. I can tell you now, we're not ready to publish the State of Secret Sprawl for 2023 from Git Guardian, but the numbers for I'm seeing are trending up. Like more commits containing secrets per 1,000 commits being made. It's unfortunately a growing problem, not a problem that's getting better.
Yeah, but you're really right about the fact that probably almost no one starts their career with, okay, let's first learn how to Git, because you just probably start to learn some topic, is it some static site generator or something, and at some point you learn that, okay, I want to host it, so I should just put it into a Git repo. And at some point you start to wonder, why does it take so long? And you see that all your node modules are included. Then you learn about the git ignore, but you probably forget about the fact that it was already in the history, and those are the things that you already mentioned, that that probably some lack of education, especially at the beginning, because really when we think about security, we think about many things. About mostly when we focus on security, we think about all those input and outputs. About in short, we think about the code itself rather than the way how we store it. So this is a very common problem of just some lacks of education, that and it's quite hard to, especially at the beginning, to try to interest people in, okay, but before you start working on this cool project, learn how to Git, because let's be honest, Git isn't something interesting. It's a great tool. It's a great tool that can help us in so many ways, but
it almost falls into Hofstadter's law, where Hofstadter's law is, in order to understand recursion, you have to understand recursion. Like, to understand and use Git properly, you really should know Git. Like that. That's it's kind of, I think Git is presented in a lot of organizations, and it's not something you can like, hey, I'm going to go learn like JavaScript. I'm going to learn how JavaScript works from the inside out, and learn how an initial call will go all the way through the stack and work all its way back. I can learn that fundamental concept in isolation, and it will help me later as I'm thinking through how JavaScript works. Git requires it to be much more hands-on and situational. Like, yes, you can conceptually learn how objects are packed, but that doesn't really tell you like day to day how you're going to use Git, or look at Git diffs, or do a merge request. You have to go through those processes to get there. And hopefully someone on the other end that's accepting those merge requests is pushing for better practices throughout. I just realized earlier you asked me about keeping secrets out of code. And I didn't talk about, and I'm surprised I didn't bring it up, one of my favorite parts of Git that can help with that. And that's the Git hooks.
That's true. We
so
forgot about this, and this is a very, very interesting.
This is one of the most important parts of Git. So Git, back when Linus and Gitster were working on it originally, it was just a way for Linus to manage how he was dealing with packages. So he wrote all these scripts in Perl, put them all together, and slowly they've changed it all out to C code, almost all of it, and other languages as well. But it was scripts. So he needed ways like, if this happens, I needed to trigger these things to run. So that's where the idea of hooks came from. It's like, all right, there's going to be these hook points inside the plumbing of Git, and when a certain threshold gets crossed, let's go ahead and look in this folder, see if there's something called this particular name, and if it's there, let's run whatever's in that file. That's what a Git hook is. There are 17 of them. Githooks.com. I have no affiliation with Matthew Hudson. Awesome website, but if you don't visit any other website after this one from my particular appearance here, go look at githooks.com. It will give you a great springboard into the world of what you can possibly do. There are 3 Git hooks that exist before a commit is actually made. There is a pre-push hook that will help you do any kind of checking you need before code leaves your machine. And on the server end of it, there are hooks like pre-receive, which can actually do some kind of checking before code is actually accepted on the server. I bring up those 3 points in time specifically because if you're trying to keep hard-coded credentials out of your source code, your shared code repository, these are the 3 places where I think it makes the most sense to check to see if you got any hard-coded credentials. There are some awesome open source tools out there. I will plug mine, GG Shield. It's part of the GitGuardian platform. It does require access to the GitGuardian API. If you're using like AWS specifically and totally and wholly, AWS Labs made something called Git Secrets, which is pretty handy. There are other open source tools out there that I'm not going to mention. You can find these on your own, but like look for Git pre-commit hook secret detection. If you Google that, you're going to find your options. Probably GG Shield at the top. But anyway, this is something you can do as a local developer to, even before you make a commit, have it stop you and say, look, you got a hard-coded secret here. I'm not going to do the commit until you fix this. If you fix it there is no harm done. Unless someone had access to your machine before you made that commit, there's no way they're going to get a hold of your password or your credentials that you're hard-coding, your API keys and whatnot. If you do it on pre-push, not as good as pre-commit because now you still have that last commit that you need to clean up. But I can tell you, cleaning up the last commit is way easier than cleaning up a commit from like 4 or 5 commits back. It's just you remove the head, you start over, you reapply it. It's really, really simple. Once it's pushed, though, once it's actually merged into the repository, now you have to do a coordinated effort with everyone else that has that repo to get rid of that at the same time. Because if not everyone does it and there's one copy floating out there, then one copy's floating out there. Now you got to invalidate the key. Now you got to figure out what to do with the team. And that's where pre-receive really comes in. If you're a GitHub owner or you're running GitLab self-managed, there's no reason you shouldn't set up a pre-receive hook to automatically protect your repo. Say, hey, you're trying to push a credential in here. Stop. Don't do that. The developer will get a message that, hey, this failed because this hook failed.
And tell me, okay, so let's go to a scenario when, we messed it up. We hard-coded, we pushed it, we didn't use any protection, so it landed in the public Git repository. So step by step, what should we do to clean this mess up?
First, don't panic. If you notice that, hey, we got a credential in our repo, figure out a few data points. I think the most important ones are how old is it? If it's brand new, you probably have time to act before anybody exploits it. Might not. If it's a public repo, you have less than 30 seconds before a bot has scraped it. So there is a feed from GitHub. All of them have something like this, but GitHub specifically has the feed. You can look at every single push that happens to a public repo. Guarantee you there are bad actors in the world who do this constantly. There are also good guys who do this, who are looking through good actors. who are doing it for Good Samaritan reasons, like GitGuardian, where we're really trying to identify it and notify people before something bad happens. But if it's a private repo and it just happened, okay, we can act with urgency, but it's probably still valid. Also, where is it? Is it and what is it? Is it a Slack incoming Git hook, or a Slack incoming webhook? What's the real danger here? Like, can someone push messages into our Slack instance? Okay, that's bad, but how bad is that? That's going to depend on your situation.
Let's say it was a very critical database password. Let's go big.
Okay, that's different matter altogether. And that's the third thing is it still valid? Age will tell you, it will kind of indicate that it might be valid, but the only way to know if it's valid is to check. Once you know, hey, this is valid, we need to act, it's really important to communicate with the other teams that might be affected. If you go ahead and just revoke it, what goes down? Unless you built the system completely by yourself and know every single part of your DevOps setup, you might do more harm than good by just immediately revoking something. But that depends. It's very situational. Communicate with your team as quick as you can, including the developer who put it there. If you're not the developer who put that code there, there is this thing in Git called blame. You can simply look at the commit and see the email address and the name of the person who pushed that code. Get them on Slack, get them on the phone, figure out, like, why is this here? It might be, oh, that's a test credential, I forgot to comment that. Oh, this only goes to an imaginary server. And this is just an example of what the key would look like that you should use, that you should put in Vault. Like, oh, okay, that makes sense. It'd probably be invalid, and that's why validation is important to add to that urgency, because then the developer might say, oh my god, I did not know that was there. What do we do now? Now everyone's on board. Now you've identified, like, hey, this, and that developer probably already has a better idea of what it's connected to and what else is connected to those systems. Once you have a pretty good idea of, like, all right, what do we do? Now it's time to rotate that key, invalidate it, get a new one in there. So even if you don't clean out the secret that did get leaked into your repo, at least it doesn't work. And now it's up to you, like, how difficult will it be to clean this up? Again, if it's a brand new push, you can simply send out an alert like, hey, nobody do a Git pull. We're cleaning the repo real quick. Clean the repo, then tell everyone to do a Git pull and get the new version, and then keep going with their day. Versus everyone, you find it 3 days later, everyone's done a Git pull and they're in different states with the repos and different pushes have happened, and that's a nightmare to clean up. So it depends on, it's really up to you if you clean up your Git repo from invalid secrets. But for valid secrets, breathe, make a plan, communicate, and only rotate when you know the ramifications. And then finally, that's where access logs come in. So start looking through your logs. Like, hey, did anybody actually use this key? Did anyone use it from an unexpected place? Is that IP within our subnet? Oh, then it was just a developer who used it, and they probably the same developer put it there in the first place. Not a big deal. But, like, I don't recognize these IP addresses. That's a big problem. So it depends on the situation.
Okay. But still, one of the most important things that you mentioned at the beginning, don't panic.
Yeah, don't. Everyone's gone through this at some point. If you're in DevOps for any length of time, this will probably happen to you. That's not a good thing, but that's reality. You're not alone.
Yeah, I mean, it's not something that I'm proud of, but did I push an env file once or twice? Yes, I did. Yeah. It happens. Yeah, it totally happens.
This actually, one more point in there, and I say don't panic, don't rotate that key unless you know exactly what it goes to. There is a concept of secret management maturity out there that you can find various blog posts and white papers on. But one thing that everybody points to is that very mature organizations, expert organizations, will have auto rotation already in place. This is one of the other advantages to things like Key Vault and secret managers on systems. is some of them, like AWS, has like advanced settings where it will auto rotate things as fast as you want them to. I think you set it down to like 15 minutes.
Mhm.
But you can definitely daily. If you're in the habit of rotating keys very, very often, these events don't really cause that much panic. It's like, oh, rotate the keys again. Great. We did it on a script run instead of the daily cron. No big deal. Like, nobody's sweating. If you've never rotated keys for your database, that's when the real panic's going to set in. Like, how do I do
Mhm.
that? I have no idea what this will do. Versus, I do this every day. It's just one extra rotation. Great. And it's very different scenarios.
Yeah, I understand. And tell me, okay, if we have a new developer that is really starting his adventure and he's listening to us, let's say, and he's kind of worried about maybe he will leak a password. So how such a person should start uh, preparing his environment, because it's all about preparing the environment, preparing some things in the background to make sure that his code, his Git repository will be much more secure than not.
Wow. Yeah, it's such a broad topic.
Oh yes, it is. Yeah, because it's kind of philosophic. Let's be honest. It's in many parts. It's not entirely about the tech itself, because there are some few things that we have different tools to use. But in general, it's about the way how we work. As you mentioned about the key rotation, it's the way how we work. We can use different tools for this, but in general, it's about the philosophy of how
Mhm.
we work, how we store our keys, how we have a possibility to rotate them, and the tools doesn't matter in general. Mhm.
Yeah. So thinking through just some philosophical points for people starting out. One, understanding that Git in and of itself is an awesome tool that also has some security pitfalls just built in. Know that everyone that has a copy of your repo has a copy of every single version of the file going in. That's good basic knowledge to grasp, that if I push a new commit that took out the secret and I put in the commit message, removed the AWS key, guess what? You've just put up a giant sign that says, attackers, please look through my history. That's exactly
Mhm.
what they're going to look for. To assume that any private repo will eventually be public. It probably won't. There's a good possibility that private repos will stay private, but it's so easy to, one, push to the wrong remote. You can set up as many remotes as you need, or accidentally take, or someone in your org take a private repo public. It's so easy to do. It's like 2 button pushes in GitHub. You do
Mhm.
have a warning label inside of the GitHub UI, but if you're doing it from the command line, you just can override it and just go. Um, that's another reason, like, detection is really important, like setting up perimeter detection and seeing like, hey, uh, this secret ended up somewhere where I didn't expect it to be. Have some kind of tool out there that is automatically looking for you. Actually, true story. Before I started working for GitGuardian,
Mhm.
I was migrating, and I did a really lazy thing. I just was going to move my SSH key to a new machine, and like, all right, I'm just going to keep the same SSH key. Then GitHub's none the wiser. And I accidentally pushed my private SSH key to a public repo. Um, yeah, immediately got an email from GitGuardian through their a Good Samaritan program, like, hey, did you know this is in a public repo? And my first gut instinct was like, no, it's not. This is wrong. And I jumped on GitHub. I was like, uh oh. So immediately made that private. Next thing was I rotated everywhere that SSH key, the thing I was trying to avoid in the first place, uh, and just did it faster than I anticipated doing it. So don't just create new SSH keys. They're really, really simple to make. Just create new ones. So don't do that. Um, a third, when in doubt, uh, rotate. If there's any question of like, what am I doing with this, or like who has access to this key, and you're using it locally, it's probably time to like, hey, I don't know how old this is. maybe we should rotate this. Rotate more often than you think is necessary. That's more for secrets than it is for Git. Other than for Git, leverage Git ignore. Starting from complete scratch, using a local .env file and Git ignore is light years better than hard coding a secret.
Mm-hmm.
Using an encrypted env file in place through using like tools like Mozilla has a tool called SOPS, SOPS, all caps. It is an encryption in use tool where the only time you see the plain text is while you're editing the file, but the env file will then be encrypted in whatever encryption methodology you choose on your local machine. So if anybody gets a hold of that and doesn't know exactly how to open it and exactly what encryption program you used, they'll just get a giant weird binary file and won't be able to read it. They might see the structure, but that's another step up. So I'm not ready to go to key management and HashiCorp Vault, but I am ready to step up my game a little bit. That's a good next easy step. Vault is the next after that. It's much heavier handed, but the nice thing about HashiCorp Vault is you can integrate it with your other systems. So if you're building a private cloud, building your own platform, really, this will take care of this problem for you. So now you have one place to store your keys and manage them from one central location. Otherwise, you are setting up new keys through IAM through your platforms, which is an important thing to know how to do. I think the longer you use a platform, the more secure you can make it over time. And that's the last big philosophical point is don't get overwhelmed with this stuff. It is a journey. Every company's on this journey. Every developer's on this journey. Nobody's born knowing this stuff. I've been doing this since 2005 overall, and every day I learn something new. Literally every day I discover some kind of new vulnerability or new best practice around, well, not just code, but really everything in tech.
Yeah, I mean, especially with the last point you mentioned, I'm with you because as a developer, I'm also constantly learning new things, and this is also the way how technology works. Every day there is something new, so there are also new ways how we can secure different parts of our code, of our repository, and we can automate more and more things. Oh, and by the way, also remember about all those use Git hooks for security. This is also quite because this will kind of take it out of your head, because someone will make sure that that your code is reviewed in some way. That I think that we
there's sorry, just one last point, and it sounds like a non sequitur, but enable multi-factor authentication on everything.
Of course,
and this is important because legacy GitHub URLs, I think you can still do it. You if you're making calls to private repos, you used to embed username passwords in the URL. And then if you're using that as a remote, that can easily be stored inside of a Git folder. If you're using like a proper Git hosting, that doesn't really factor into it. But again, we found last year over 2 million repos that weren't in places with Git hosting. There were just in S3 buckets. A giant chunk of those contained those strings that contained username password. That's bad, but if you have multi-factor authentication and no one can get into your account, then you're a little bit safer. So MFA, all the things, anytime sensitive data is ever going to be in play.
Yeah. Also, that's true, because still getting getting access to just the Git folder can show you a lot of secrets. And on the other hand, we have to remember that people who are trying to use data that they found in those repositories, they tend to connect the dots. So they will find a part in our repository. They will then try to look for where else did this email leaked in some way. So thanks to
Mhm.
connecting the dots and using some bad practices, like for example using the same password in many places, they can have access to a lot of things that we trying to prevent them from having access to. So yeah, it's yeah, and
Have very long passwords that you don't know. That's
oh,
my
that's true.
philosophy. I know one password and I rotate it at least once a month, and that goes to I'm not gonna say the name of my provider, but that's where it goes. I use another one
Mhm.
for work, but I use biometrics for that. My fingerprint gets me in, but I do have to know a very long master password for that one as well. Um, but I'm safe in the knowledge that without that encryption, without that level of local encryption, decryption, that someone can have access to that my encrypted file on the internet. Good luck. Like you're never going to guess that password. It's long enough; it'll take you a billion years.
Exactly. Yeah. So, Dwayne, thank you so much for sharing all your knowledge about Git security, because we covered really quite a lot, and I really hope that many of you will learn something from this, or maybe you will show this video to people who are starting their adventure with mostly development, because like we mentioned earlier, uh, in most cases you don't learn how to Git, you just start to use it and you make mistakes, and it's good that during this video you will find this step by step what to do if you made this horrible mistake of making some of your secret passwords public.
So if I can
Dwayne.
make one last
Oh
plug,
yeah, of course.
um, this is across the board. Git isn't used in isolation. Git is a ultimate transport mechanism and collaboration tool for getting your code to other places. All of those other places, like Kinsta, like AWS, like Google Cloud, all want you to succeed and be safe. All of them do. All of them have written documentation on how best to think about Git security somewhere in their docs, somewhere in their blog. I guarantee you they all have some kind of paper on this. Go read it. If you have questions, support people love answering questions about Git. Not like deep philosophical questions about it, but like on your platform, I'm trying to do this with Git. Guarantee you that is a question that they would enjoy answering. So if you have questions, reach out to your providers, ask them, but also read their best practices because again, they want you to succeed.
Yeah, that's true. I mean, I'm sure that every support would prefer to answer how to prevent something rather than, yeah, your database password just leaked, what should we do? Because then it becomes a true problem, and before this it's just a question without any panic in the meantime, without any stress, because it's just a simple question. And you are right. Every good hosting company should help you with something like this. If they don't, you probably should think about changing your hosting company, because this is kind of a bad sign about them. Yeah. So, Dwayne, like I said, thank you once again for sharing all your knowledge, and also it was really great to learn that you are also on the light roasted coffee team, because yeah, I think this
On the
is
way to go.
I let's be honest, this is the best team. So, cheers,
So
and everyone have a great day. See you next time. Bye.